Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to visualize a correlation matrix using RStudio. Even before I proceed to demonstrate how to visualize the data using RStudio, may I request you to subscribe to my channel, also like and share my videos. Let me begin by introducing you to the data set that I'll be working on. This is a very popular data set, which is called as the Boston housing data set. There are 14 columns and 506 rows in the original data set. You can pick up this data set from Kaggle. It is publicly available. For the purpose of simplicity, I've just retained top 6 of the variables. As you can see here, some of the important variables that I have in this data set are the crime rate. The first variable is crime rate. Next, I have nitrogen oxide concentration, which is measured in parts per million. The average number of rooms. The fourth variable is the number of Black population. Then you have lower status of population. Finally, you have a very important variable which represents the median value of homes in Boston. So these are the 6 variables that I will be using to generate a correlation matrix. We will be also looking at how you can easily visualize this correlation matrix through a very interesting graphs. Now, when you look at the sample size of this data, you can see here, when I select the first row, the count of observations here in Excel is 506, which means that I have got a healthy sample to perform analysis on. With this background about the data set, let me now proceed to demonstrate in RStudio how you can generate a correlation matrix and use this correlation matrix to perform a visual display of the data. I will be using RStudio to perform the correlation matrix. As you can see here, this is the interface of RStudio. I will be primarily using RStudio for this analysis. The first thing that we need to do when we do any analysis in RStudio is to import the data set. To import the data set, I will be using a simple command which is called as read.csv. I repeat, there's a very simple command which is called as read.csv. So this is the first thing that I'll be doing, read.csv. Within read.csv, I will be specifying the location of the file. This is a CSV file, and hence I'm using comma as the separator value. Finally, the first row consists of the variable names, and hence I have specified the header as true. Let me go ahead and use the read.csv command to import this particular file in RStudio. Once I click on Control Enter, you can see here the code has been executed and I'm saving the file as Boston. To view the contents of the file, you can use the view command. I'll be specifying view of Boston here. Let me go ahead and execute this particular command. The moment I execute this particular command, you can see here there are 6 variables in the data set. First is crime rate. Second is nitrogen oxide concentration. Then you have the average number of rooms, so on and so forth. We have 506 entries with 6 columns. Let me close this particular file. Now, the next step would be to perform correlation. How do we perform correlation in R? Let me quickly show you the command which allows us to perform the correlation. you can see here, there is a very simple command which is called as the Corr command or the Corr function. I will be running the Corr command on the Boston dataset. You can see here, the moment I click on Boston, it is pointing to the Boston file which we have imported. So what this command does is, it will generate a correlation matrix, and that correlation matrix will be saved as an object called Corr_matrix. Let me go ahead and execute this particular command. The code has run successfully. Since the code has run successfully, we do not have to worry about debugging any error and such things. To look at the contents of the correlation matrix, you can copy the object and execute the command. You can clearly see here, this would be the correlation matrix. You have different variables like crime rate, nitrogen oxide concentration, average number of rooms, the black population, the percentage of lowest strata of population, then you have the median value. One interesting thing to observe here is the correlation values will always lie between -1 and +1. This is the range of correlation. It always lies between -1 and +1. Now, since we have 25 different values for correlation, it becomes a bit difficult to visualize this. It becomes a bit difficult to comprehend what does this correlation matrix tell me. So to pull out interesting insights from this correlation matrix, I will be using a very interesting plot which is called as the Corr plot. But even before I proceed to show how to use the Corr plot, as you can see here, I would like to reduce the decimals to only one value. So in the next command, what I'm going to do is I'm going to round the correlation values to one decimal place only. I repeat, I can round the correlation values to one decimal place only. So in line number 9, you can see we are attempting to round the correlation values to one decimal place. We can use the round command, and as the input, we can feed correlation matrix. Let me go ahead and execute this particular object. Now, I've saved the result in an object which is called as Corr_matrix_rounded. Let me now execute this particular object. You can see here the correlation matrix appears like this. It's a lot easier to comprehend the correlation matrix when it is rounded to only one decimal place. Now, we are going to install a package which is called as the corrplot. How do we do this? To install this particular package, you need to run a command which is called as install.packages of corrplot. In line number 13, you can see here, we are trying to load the corrplot package. This is the name of the package which is called as corrplot. And in line number 15, we will be running the library for corrplot. I would like to take a moment to explain the corrplot package. In R, we have a wonderful package which is called as corrplot, which has a function called as the corrplot function. We can use the corrplot function to create a graphical representation of the correlation matrix. I repeat, we can use the corrplot function to create a graphical representation of the correlation matrix. A correlation matrix is a table that shows the pairwise correlations between a set of variables. The corrplot function allows you to create a visually appealing and easy to read plot that displays the correlations in a matrix. Now, you may ask me, what is the advantage of the corrplot function? The corrplot is a plot that can be used to identify patterns of correlation between the variables, which can be useful for data analysis and data exploration. I repeat, the corrplot function can be used to identify patterns of correlation between the variables, which can be useful for data analysis and data exploration. The corrplot function provides various options to customize the plot. Some of the options are coloring the cells, the type of correlation coefficient that we want to use, that is Pearson's or Spearman's rank correlation. Overall, I can say that the corrplot function in R is a very, very useful tool for visualizing and understanding the correlations in a correlation matrix. I've already installed this package, and therefore I'll only be calling the library corrplot. Let me go ahead and execute the corrplot library. Once you activate the library, the next step would be to run the corrplot function. There are quite a few arguments in this particular function, so let me clarify this one by one. You can see here, in line number 17, I will be creating a correlation matrix plot with circles and values. I repeat, in line number 17, I will be creating a correlation matrix plot with circles and values. I know that there are a lot of arguments, so let me just explain this one by one. So this is the corrplot function that I'll be using. The first value that I'm specifying is the name of the object, which consists of the correlation values. Remember, the Corr underscore matrix underscore rounded. This is the name of the object which has the correlation matrix values. So this is the first value that I'll be specifying. The second argument here is method. Now in R, there are 7 different values that you can specify for method. You can specify circle or square or ellipse or number or shade or color or pie or none. Any of these options can be specified. I'm going to change the existing value of square to circle. We can experiment with other methods as well at a later stage. Next, you have type. Under the type argument, I'm specifying the value as lower. What does the lower value do? Now, when we say type, the type of the correlation matrix to be displayed, we can specify the values as full or upper or lower or diagonal. When we specify this as lower, a lower triangular part of the correlation matrix is displayed, not the upper part, because the upper would then be a mirror image of the lower part of the correlation matrix. So when I specify lower here, we will be getting a lower triangular matrix which has the correlation values. The next parameter here would be order. What is this order? The order in which the variables should be displayed. I repeat, the order specifies the order in which the variable should be displayed in the corrplot. It can be based on alphabetical order, or we can choose to display the correlation in the original order that we have fed the data. You can also use certain algorithms like hierarchical clustering and k-means. I'm going to keep it at hierarchical clustering. There are other additional arguments like add coef dot cull. Add coefficient dot color. Now, what does this mean? Add coefficient dot color is an option which allows you to specify the color of the correlation coefficients. I repeat, this argument allows you to specify the color of the correlation coefficients. In this example, we are using the black color to display the values of the correlations in black. Next, we have number.cex. I repeat, number.cex. This is used to control the size of the correlation coefficient. I'm specifying the value as 0.7. Then we have T1.col. Now, this is used to specify the color. Further, what we have is T1.srt. The earlier option was T1.color. Now we have T1.srt. One small correction in what I said just now. This is not T1, this is TL.col. I repeat, this is TL.col. Here again, we have TL.srt. Now, what does this TL.srt do? This helps us specify the rotation angle of the variable names. I repeat, this helps us specify the rotation angle of the variable names. Here, we are using a 45-degree rotation. The last of the arguments that we have is TL.cex. This helps us control the size of the variable names. I repeat, TL.cex helps us control the size of the variable names. For further help, you can always use the help of documentation in case you need additional details. What I'm going to do now is select the corrplot function and execute the command. You can see here in the right-hand side, we are able to see the correlation matrix output. So this is the output of the corrplot function that we have got. As you can see here, in the x-axis, we have the range from -1 all the way to +1. I repeat, we have the range from -1 all the way up to +1. If a value is positive, it is shown in blue color. And if the value is negative, it is shown in red color. Darker the shade of the blue color, higher is the value of the correlation. Darker the red color, higher is the value of the negative correlation. If the correlation value is close to 0, it is shown in white. So this is the color range that can be used to interpret the correlation value here. One interesting thing that you would observe here is we have got all the variables like NOx, LSTAT, B, so on and so forth. Similarly, we have crime rate, NOx, LSTAT, B along the diagonal. There are two important points that you need to observe. One is the color of the circle, and the second one is the size of the circle. I repeat, you need to observe two important aspects: the color of the circle, and two, the size of the bubble. Let's first talk about the size of the bubble. If the bubble size is really large, it means that the magnitude of correlation is large. On the other hand, if the bubble size is small, it means that the magnitude of correlation is less. You can clearly see here, the bubble size is very large, indicating that the correlation is very high. 0.7, this is the correlation value of median value of housing price and the average number of rooms. What does this mean? It simply means that if the average number of rooms increase, the median value of homes also increase. And if the value of correlation is greater than 0.7, we tend to take it seriously as it is a high number. Similarly, you can see there is a large circle, but this is red color circle. The correlation value is minus 0.7. Remember, red color circles indicate negative correlation. Now, this is the correlation between median value of housing price and the level of lower status of population. So this simply means that as the percentage of lower status of population increases, the median value of housing price comes down. Hence, there is an inverse relationship between the median value of housing price and lower status of population. These circles which we discussed just now are quite big. Let's also pay attention to a small circle here. This is minus 0.2. Since the value is small, R is showing this as a smaller circle. Further, since there is a negative correlation value, it is indicated using red color. This is the correlation value for the average number of rooms and the crime rate in Boston housing data set. So this is how we can interpret the output of corrplot. I'd like to again summarize. There are two important observations that you need to make. One is the size of the bubble. Second one is the color of the bubble. Larger the bubble size, larger the correlation value. Smaller the bubble size, lower the correlation value. Red color bubbles indicate negative correlation. Blue color bubbles indicate positive correlation. We don't have white color bubbles here. If we would have had white color bubbles, it means that the correlation is 0. Now, there are a couple of interesting ways in which we can control the display of the corrplot. I repeat, there are a couple of interesting ways in which we can control the display of the corrplot. The first way would be to change the existing value under the method argument. We can change this to square. So instead of circle, I'm going to experiment and give the value square. If we go ahead and execute this, when I zoom this, this is how the correlation plot displays the output. You can clearly see here, instead of circles, we have squares. Let me close this. Now, instead of having a square, you can also experiment with ellipse. Let me execute this particular command. You can see for yourself as to how the values and the display of the values change in the corrplot when you specify ellipse. It depends upon the user as to what he wants to eventually show in the graph. You can specify circle, square, ellipse, or in case you don't want any of the shapes, you can just specify number. When you specify just the number, what corrplot does is it displays only the numbers. Let's have a look at the numbers. This looks pretty boring. So it's better to avoid displaying numbers. There's another interesting way in which you can specify, which is to simply shade. So you can specify instead of number, I can just type shade. Go on to execute this. You can see here, this is how the Corr plot would look if you were to specify shade as a value under the method section. Further, once we have specified shade, you can give color here. Zoom. When I zoom it, we can see how the Corr plot changes for different values of method. Now, it is not a practice, but sometimes people also tend to give the value pi here. Let me specify the method as pi and see for ourselves how does this appear. You can see here the correlation values are appearing in the form of a pi diagram. The slice indicates the magnitude of correlation. You can see here the halfway mark is shown in this way. This is the correlation between LSTAT and crime rate. Since the correlation is 0.5, 50% of the circle is colored. Similarly, when you look at the variable B and crime rate, it is negative 0.4. So when you are interpreting the pi, it depends upon whether you have a positive correlation or negative correlation. Positive correlation tends to be filled in an anti-clockwise direction. Larger the size of the slice, bigger is the value of the correlation. For negative correlation, we can interpret it in an anti-clockwise way. You can see here minus 0.7. You have to interpret this in an anti-clockwise way. If you don't want any of these methods, you can simply specify none here. In fact, there is no argument called as none, in which case we don't have to specify anything. We can go by circle. So I'll go with the default option of circle here. There is one additional thing that you can do, which is to change the values under the type section. You can see here, this is the type argument. I have specified lower, and therefore I'm getting the Corr plot as a lower triangular matrix. Instead of lower, I can also type here upper. I'm giving a different value here, and I'm specifying upper. You can see here the correlation matrix will appear like this. Instead of having a lower triangular matrix, we now have an upper triangular matrix. It is better that we give one of these two, simply because the lower triangular matrix will just be a mirror image of the upper triangular matrix. We will have to look at a lot fewer values if you either specify lower triangular matrix or the upper triangular matrix. We can also experiment with values like full. Let's specify the value as full here. Let me now look at the output of Corr plot. You're getting a lot of values. Please observe on either side of the diagonal, you just have the same numbers. 0.4 is the correlation between NOx and crime rate. You have the same value of 0.4 between NOx and crime rate. Similarly, 0.5, which is a mirror image of 0.5, minus 0.4 is a mirror image of minus 0.4, minus 0.2 would be a mirror image of minus 0.2. You have minus 0.4, which is a mirror image of minus 0.4. So since it's a mirror image, we might want to choose either lower or upper. Let me experiment with one other value here, which is diagonal, and show you how the matrix appear. I'm getting an error message which says error in match. Argument should be one of full, lower, or upper. So the diagonal value is not to be specified. So I'll just remove this and specify just lower. So this is how a corrplot function is very, very useful, and it can be used to visualize the correlation matrix. I would encourage my audience to experiment with the corrplot function. Overall, the corrplot function in R is a very useful tool for visualizing extremely complex data and understanding correlations in a correlation matrix. Now, there are a couple of things additionally that you might want to keep in mind. The first point is correlation analysis can be used as a standalone analysis, which means that once you run a correlation matrix, this could be the end of analysis. Or sometimes the output of correlation can be used as a foundation for more complex analysis, as in the case of linear regression or PCA, or principal component analysis. With this, I have come to the end of today's video. In today's video, we looked at how to visualize a correlation matrix using the corrplot package. We've seen the advantage of using the corrplot. It's a very, very powerful function, and this plot can be used to identify patterns of correlations between the variables, which can be useful for data analysis and data exploration. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.